Okay, your previous lessons were about reading dot plots. Dot plot can also be called a line plot. A lot of times a dot plot has dots and a line plot has X's, but they're basically the same thing. And so today I'm going to teach you how to create a dot plot and how to create this thing called a box and whisker plot. Okay, the box and whisker plot is the part that will be new. Really just kind of wanted to underline this because this is the part that's going to be new to you, box and whisker plot. Maybe you've seen it before. Okay, so I'm giving you this problem where there are some cousins at a family reunion, and we are going to create a dot plot of all this information. The dot plot, really what the dot plot's going to do is it's just going to put the numbers in order for us. And, I think you could probably just go ahead and list these in order from least to greatest. But let's just use a dot plot so you can understand how to use the dot plot. Okay, so I'm going to first make a line. I don't really have to start all the way with age number 0, 1, 2, but it looks like I need to start with 3. And this would be 4, 5, maybe I'll go 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I really don't even need to go up above 15. Okay, so now I'm going to come in here. I'm going to put my dots. I see a 4, so I'm going to put an X over the floor. I'm going to go ahead and make it like a line plot. Line plots use X's and dot plots use dots because the other day I did one that actually had dots. Then we're going to do an 8, which would be right here, a 3, 11, 15, 5, 4, 12, 10, and 13. Okay, you can see the most common age is 4. And that's actually called the mode, the one that's most common. But we can actually use this to analyze a lot of stuff. We can say, what is the oldest cousin? And that would be 15 years old. What if I say, what is the youngest cousin? We can say that's 3 years old. What if I say, what's the age range? Well, that's where I take the oldest and the smallest and I subtract them and I say it's 12 years. There's 12 years between the oldest and the youngest. I already mentioned mode is the one that occurred most often, and that's 4. Another word that we're going to be looking at here is the median. Probably should have moved these up. I wonder if I still can. I don't think I can. I guess I can try this again. No, not going to let me. Okay, so I'm going to scoot this over. Maybe I'll do it down here. If I ask for the median, the median, in this, I'm asking for the middle piece of data. And the middle piece of data, well, there's 10 cousins, and so there's not going to be a number exactly in the middle. So I'm going to put a little line here. 1, 2, 3, 4, 5 this way, and 1, 2, 3, 4, 5 this way. So now I actually want to look at these two right here. This represented the number 8, and this represents the number 10. So what would come between 8 and 10 would be the number 9. So we're actually going to say the median is 9, even though there's not a cousin that is 9 years old. It's what we call the median. We can find the mean of the data, which is just the average. And what we do with that is we actually add all the pieces of data together. We do 3 plus 4 plus 4 plus 5 plus 8 plus 10 plus 11 plus 12 plus 13 plus 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 7 plus 9 is 16 plus 8 is 24, 34, 45, 57, 70, that's 85 if I add them all together. And then what I do is I divide, let's see, I'll do it over here. I divide by the number of pieces of data, and there are 10 pieces of data, and 85 divided by 10 would be 8.5. So I would say that the average of the children's ages is 8.5 years old. So those are some information that we could actually gather from the box and whisker plot. Okay, so I actually want to look at this data. I'm gonna copy it. Let's see. And I'm going to paste it over here on this page. And we're going to do this other thing, which is called, this one's going to be called a box and whisker plot. And the most important thing to do first is to put the data in order, which we basically already did on this other page. We put it all in order whenever we put it into this line plot. So if I put this data in order, we've got 3, we've got 2 4s, we've got a 5, we have 10, 11, 12, 13. Oh, I forgot an 8. We've got 8, 10, 11, 12, 13, and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got them all. And the second thing you want to do is find the median. The median is the number that's in the middle. This is the one I told you on the previous page. Since there's 10 pieces of data, the middle is actually in between these two. And so the median is going to be what comes between 8 and 10, and that number is 9. So all we really do is do 8 plus 10 is 18, and then we divide by 2, and that's how we get 9. That one's kind of easy to look at and see. Now we're going to look at, this would be step 3. Step 3. We're going to look at what I call the lower quartile. And this is the lower half of the data. We're going to find the median. So if we're just looking at the lower half of the data, so we're just looking at this portion of the data, we're going to find the median of the lower half. It's the one in the middle. Now I can see this is the one in the middle. So I'm actually going to call this the lower quartile, which is 4. Okay, the fourth step would be to find the upper quartile. In this, we're going to look at the upper half of the data. And we're going to find the median of that. So I'll use my yellow again. Now I'm looking at the upper half of the data, and the median of that is 12. So we're going to call this the upper quartile. And then the last step would be to find the lower extreme and the upper extreme. And that's just the smallest number and the largest number on this list. So the smallest number would be the lower extreme, that's the number 3. And the largest number would be the upper extreme, and that's the number 15. So this is going to look sort of funny, I think. But this is another way that people represent data. We are going to make a real number line, and the number line's got to go from 3 to 15, really just like this one, okay? I don't have to go any lower than 3. I might go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I could do that. That's just sort of a different way of organizing the data. And now I'm going to make this thing called a box and whisker plot. So we're going to start with the box, and we're going to first plot the median, and we're going to draw this line because we are making a box. So it's not just going to be a dot here, it's going to be a line. So that's the median. We're going to go to the upper quartile, which is 12, and draw a line. This is the upper quartile. And the lower quartile, which is 4. This is the lower quartile. And now we're going to connect these. Okay, and then we're going to go, here's 3. We're going to draw a whisker out to 3, the lower extreme. And we're going to draw a whisker to 15, that's the upper extreme. The whole point of this is for you to understand that inside this box is actually half of the data. This is the middle half of the data lies inside the box.